Hey everyone, today we're going to walk through the test that we did on Friday. So question 1. The line L1 has equation 4y minus 3x is equal to 10. We might want to first rearrange that before we do anything else. Before we do any calculations, just rearrange that into y is equal to something. So if 4y minus 3x is going to be equal to 10, then you take this 3x, move it up there, make that plus 3x, and then you have just 4y on its own. So you divide everything by 4, that would be 3 over 4x plus 10 over 4, which is 2.5 I believe, so 5 over 2. So that's good. And then line 2 passes through 2 points. So from the 2 points you can get the equation of a straight line. So line 2, L2, colon, we're given this point and this point. So we want to figure out the gradient by doing the difference in y over the difference in x. So that's the difference in y. So that's 8 minus negative 1, which is going to be 8 plus 1. And then we have negative 1 minus 5. That's the difference in x. And that's going to be equal to, the top is going to be equal to 9, and the bottom is going to be equal to negative 6. Yep, looks like it. So that's going to be negative 3 over 2. Okay, and it's asking us whether the lines are parallel, perpendicular, or neither of those. So if it's parallel, right? So the definition of parallel lines. Okay, so if L1 is parallel to L2, then that means the gradient of L1 must equal the gradient of L2. Okay, and here we have, well, this is our gradient. Okay, for L2, so that's negative 3 over 2. But for L1 we have 3 over 4, which is not the same. So it is, well, so we have shown that gradient of L1 is not equal gradient of L2, therefore it's not parallel. And now we want to look at if it's perpendicular or not. So the definition of perpendicular lines in 2D is if L1 is parallel to L2, then the gradient of L1 times the gradient of L2 is going to be equal to negative 1. So let's test that. So gradient of L1 times gradient of L2, that is going to be 3 over 4, 3 over 4 times negative 3 over 2. And that's going to give us negative 9 over positive 6, which simplifies to, nope, it's 4 times 2, not 6. That's going to be negative 9 over 8, which is not negative 1. Therefore, they're not perpendicular either. Not perpendicular. So, we can conclude that they are neither. The lines are neither parallel nor perpendicular. I'm just writing these symbols because I'm lazy. You should really write the words parallel and perpendicular. So don't be like me. Alright, question 2. Part 1. Show that x squared minus 8x plus 17 is bigger than 0 for all real values of x. So there are a couple ways of doing this. The most straightforward way is you take this expression, complete the square, so turn it into completed square form, and then basically solve for 0, I think. Yep. So x squared minus 8x plus 17 if you complete the square, so you're going to have 8x minus, well, 8 over 2, that's going to be 4 squared, and then you have to subtract the square of 4 from that, so it's going to be 16, and then you have your constant, which is plus 17, and that's going to be equal to x minus 4 squared plus 1. So the explanation here is any number squared is always going to be positive, no matter what x is. Always bigger than 0, bigger than or equal to 0. And then if you add 1 to it, then that factors in, so now it's always bigger than or equal to 1. There you go. So that's the most straightforward way to prove that this expression will always be bigger than 0, because you've also proved that it's going to be, the minimum is going to be 1. Alright. Another way, another possible way of doing this is by taking this expression as a function and then differentiating it and finding the minimum point. So that's more long-winded. It's not the way you're supposed to do it, but it's a way that also works. So if you know, you just want the most straightforward way, you're done with this question, just skip to the next one. So if y is equal x squared minus 8x plus 17, then if you differentiate that, dy over dx is going to be 2x minus 8, the constant term goes away, and if you want to find a turning point in the graph, so to speak, you want to make dy over dx equal to be 0. Right, so that means 2x minus 8 is going to be 0, so 2x is going to be equal to 8, so x is going to be equal to 4, which is the same 4 as we got here from completing the square. So x is equal 4. That's cool. And then you want to prove that it is indeed a minimum point. So you're going to differentiate it again. D squared y over dx squared. We're going to take this expression and differentiate it with respect to x. So that's going to be 2. And the negative a just goes away as a constant term. So we have proved that the second derivative is always going to be positive. That means when x is equal 4, y is at a minimum. Okay, and you want to prove that that minimum point is bigger than 0. So you just want to plug in x is equal 4 into that. So y, when x is equal 4, is going to be 4 squared minus 8 times 4, and then plus 17. So that's going to be 16 minus 32 plus 17. So 16 plus 17 is 33. So that minus 32 is going to be 1, which is bigger than 0. So minimum point, minimum value of y, value of x squared minus 8x plus 17 is bigger than 0. Therefore, for any value, it's also going to be bigger than 0. Alright, so that's cool. That's not the way you're supposed to do it, so I'm just going to get rid of that, because if you did this, you're just extra, okay? Okay, next guy. So, part 2, if I add 3 to a number and square the sum, the result is going to be greater than the square of the original number. So that's an expression. We're going to write it mathematically. So we're going to let x be the number that you're talking about. So if you add 3 to it, so x plus 3, and then you square the sum, so you have it in brackets and it's squared, you're saying that the result is going to be greater than the square of the original number, which is x. So that's what they're trying to say. And you want to prove is this if this is always true, if this is sometimes true, or if this is never true. So let's say if x plus 3 squared is going to be bigger than x squared, we're going to assume that it is going to be true, and then we're going to find values for x in which is going to be true. Okay, so if true, okay, so x plus 3 squared, you can write that, you can expand out the bracket and get x squared plus 6x plus 9, and you're saying that that's going to be bigger than x squared, so the x squareds, they cancel out, so you're going to be left with 6x plus 9 is bigger than 0. So you can already see that obviously it might not be true for all values of x, because this is a straight line, and you're taking the portion of the straight line where its y coordinate is above the x-axis. But you know, a straight line goes on forever, so as long as it has a non-zero gradient, it's always, you know, it's always going to pass through the x-axis and go down. So, but when this is true, x is going to be equal to negative 3 over 2. Yep. Sorry, that's a bigger than. So we have found a range of values for which this statement is true. This whole statement, and that's going to be when x is bigger than negative 3 over 2, which is not all values, because you know x can be something smaller than negative 3 over 2. You know, it can be negative 9,000, and then that statement will not be true. But if x is bigger than negative 3 over 2, then it is true. That means, I'm just going to write that down, statement is true when x is bigger than negative 3 over 2. So, not always true. But not always false. So it is sometimes true. There you have it. Yeah, I think that's it. That's a reason. Okay, next guy. Circle C has equation this. You want to find the coordinates of the center and the radius. So what you want to do is you want to collect the x terms and then collect the y terms, and then you want to complete the square. So you can rewrite this as x squared minus xx, okay, and then plus y squared plus 10y, and then plus 9 is equal 0. Okay, I'm just going to move that over a little bit. There we have it. And then when you complete the square for this, you're going to take, you know, this guy over 2, which is x minus 3 squared, and you're going to want to take away 3 squared, which is 9. And then complete the square for this guy, you're going to take this over 2, which is 5, so y plus 5 squared, and then you want to take away 5 squared, which is 25, and then plus 9 is going to be equal to 0. You can see that's a minus 9, that's a plus 9, they cancel out. So now we're left with x minus 3 squared plus y plus 5 squared is equal, we're going to put that on the other side, reverse the sign, that's going to be positive 25. So this means if you have imagine this as Pythagoras' theorem. If you take the square root of both sides, that looks like a Pythagoras theorem thing. You're looking at distances. So say you have 3 here. 3 and negative 5. That's your x, and that's your y. Alright, so x would be some distance away from 3, and that distance is going to be x minus 3. And y is going to be some distance away from negative 5, so that's going to be y minus negative 5. And then you square both of them, and then you add them together. And then you take the square root, and then you're going to have the radius to the circle. So that means this is 5 squared. And that's your radius. So your center is going to be 3, negative 5. And radius is equal 5. There you have it. Sorry, I don't know what happened to my brain. I just stopped being able to speak. Okay, so now we have the circle. Okay, now it's saying there's a line with the equation y is equal kx. K is some constant, so it's a straight line. It cuts the circle at 2 distinct points. So we're going to have a circle. We're going to have a circle, and we're going to have a line that cuts it at 2 points. Okay, so we want to substitute y to be kx. So we just want to kind of copy this equation right here. I just realized I didn't actually write that, so I'm going to have to write it for the first time. So replace y, every single instance of y, with kx. Okay, so y squared is going to be equal kx all squared. Okay, it's minus 6x plus 10 times kx plus 9 is going to be equal 0. So if you square both things, you're going to have x squared plus k squared x squared. Okay, and that's a 1x squared plus k squared x squared. So you can factorize out the x squared, and you're going to get 1 plus k, or k plus k squared plus 1. Okay, and then here you have 10k, you have negative 6. So you're going to factorize out the x, and you're going to get 10k minus 6, and then your constant term plus 9 is equal to 0. That looks like a quadratic equation. And what do we do when we have quadratic equations? It says it cuts the circle at 2 different points. That means this quadratic equation has 2 different solutions for x. So that means we're going to look at the discriminant, because you remember this discriminant, when discriminant is bigger than 0, there are 2 solutions for x. When the discriminant is equal to 0, then there is 1 solution. And when the discriminant is smaller than 0, then there are 2 real solutions anyway. There are no purely real solutions. Basically, just don't care about this. I'm just rambling. Basically, this is what you want to look at, because it's given that we have 2 solutions. So the discriminant, you remember, when you solve a quadratic, you're going to have, x is equal to negative b plus or minus b squared minus 4ac, alright, then over 2a. This guy is the discriminant, so the discriminant is equal to b squared minus 4ac. It's what's under the square root there. So b is the coefficient of x, so that's going to be this guy. So 10k minus 6 all squared, and then minus 4 a is the coefficient of x squared, which is this guy, so k squared plus 1. And then c is going to be your constant term, 9. And we're saying that guy is bigger than 0 because it has 2 solutions. So if you square out the brackets, you get 100k squared minus 6 times 10 times 2, 60 times 2, that's going to be 120k, I believe. Yep, okay. 120k and then plus 36, and then you have 4 times 9, which is 36. So minus 36k squared and minus 36 is going to be bigger than 0. You can see that plus 36 and minus 36 cancel out. And you have 2 k squared terms, so you're going to merge them. So 100 minus 36 is going to be 64k squared minus 120k is going to be bigger than 0. So you can factorize out k, but you don't want to eliminate it by bringing it to the other side. You just want to do this. K times 64k minus 120 is bigger than 0, and obviously you can do some simplifying by dividing both sides by 8. Actually, no, I mean both terms by 8. So that means k times 8k minus, that's a 15. It's going to be bigger than 0. So let's draw a graph of k. Let's draw a graph of y is equal discriminant and x is equal k. Alright, so we want, it's going to look something like this. Okay, because when this is equal 0, then the whole thing is equal 0, and when this is equal 0, then the whole thing equals 0. So that means we have this point is 15 over 8, and this point is 0. And I know that it looks like a u and not an n because in here we had a positive coefficient and not a negative one. Because if you have ax squared plus bx plus c, and when a is bigger than 0, then that's what it looks like. When a is smaller than 0, then that's what it looks like. And now in this case, a is bigger than 0 because it is positive 64. So it's going to look like this guy. So we want it to be bigger than 0. So you're going to want to take this part and this part. So we either want it to be smaller than 0 or bigger than 15 over 8. Therefore, k is smaller than 0 or k is bigger than 15 over 8. There you have it. Next guy. Oh, I like this. So you're trying to solve an equation, obviously this guy does it wrong. And you want to identify 2 errors made by this student. Alright. So they're trying to use the subtraction law. Let's see how they did. They have 2 log x base 2 minus log of square root x base 2. And then that's what they did. See, okay, the thing is, right, if this were 2, that would be fine. But it's not. So that's wrong. So the error is the subtraction law. The subtraction law, by the way, is log a minus log b is going to be equal to log a over b, But notice that, you know, there's no coefficient here. So you're going to have to assume that they're either both 1 or they're both the same coefficient. But in here they're different because one is 2 and one is 1. So like you can have n log a minus n log b is going to be n log a over b. But if it's like m log a, then it doesn't work. So that's what that student did, because we have a 2 here, but we only have a 1 here, so that doesn't work. Subtraction law only applies when the logarithms are actually no have same coefficient. Okay, so that's the first thing that they did wrong. Let's now assume that this part is right, and then let's see how they go. So they're simplifying it. Okay, x over root x is going to be root x. Yeah, that's correct. And then you have you put there, you square the square root, so now you get rid of the square root, and then you have log x base 2 is equal to 3. But then you're saying that x is going to be equal to 3 to the second power. Okay, that's wrong, because this is the base and this is the exponent, so it should be 2 to the third power and not 3 to the second power. Okay, because the base of log is equal to the base in exponentiation. Okay, so when you have the little subscript here, that's what you'd want to put at the bottom. This guy switched it around, so that's wrong. That's why. Okay, so now we're going to solve it correctly. So the original equation is 2 log x base 2 minus log square root x base 2 is equal to 3. So what we want to do before we do the subtraction law is we want to make sure that they have the same coefficient. So I'm going to do that. I'm going to bring the 2 into the x as an exponent. So I'm going to do log x squared with base 2. And then I'm going to do log just square root x, same thing. It's equal to 3. Now they have the same coefficient, right? So now we can do the subtraction law, which means we can do this. So we can do x squared over root x. Okay, it's equal to 3. So x squared over root x is going to be, well, 2 minus a half. 2 minus a half is going to be 3 over 2. That's going to be equal to 3. Right, so we can take that out back here again. So you're going to have 3 over 2 log x base 2 is equal to 3. And you can put this in over there. So that's going to be 3 is going to cancel out. That's going to be 2. And then so x is going to be, okay, this is the base, this is the exponent. They just happen to be the same, so it's convenient. 2 to the second power, which is 4. Done. Next guy. Now we have another thing to do with logarithms. Okay, so it's saying, oh, where's my thingy? Oh, hello. Okay, v is equal p times q to the t. Okay, and the line, okay, the line says log v base 10 is equal to 0.05 t plus 4.8. Okay, and if you want to get rid of the logarithm, you're going to put v is equal 10 to this power. Okay, so 0.05 t plus 4.8, which is equal to 10 to the 4.8 times, okay, so we're changing the plus into a times now because we're splitting it up, 0.05t. So that looks like a p, okay, and that looks like a q. So now we can figure out what it is. So p is going to be 10 to the 4.8, and q is going to be 10 to the 0.05. Okay, and that's going to be 10 to the 4.8. We want 4 significant figures. So that is 63095.73 blah blah blah. If we round it to 4 sig figs, that's going to be this guy. So 63100. 4 sig figs. Q is going to be this. So just type into the calculator 0.05. That's going to be 1.122018 blah blah blah. 4 sig figs. That's going to be these guys. So 0.22. There you go. Okay. And then we want to interpret the value of constant p. So what does p stand for? What does it mean? Okay. So it's saying, v is equal p times q to the t. So the value starts at somewhere, and now it's kind of growing exponentially. So p is actually, if you sub in t is equals 0, you get this term is just equal 1, so that just equals p. That means this was the initial value of the painting. So p is the initial value of the painting, because you subbed in t is equals 0. When t is equals 0, no time has passed, so that's the initial. Q is going to be, like compound interest. You have a starting value and then you have a rate to some power. So Q is the compounding rate. Compounding, you have to write compounding, I think that's what I did and I got the mark. Yeah, compounding rate of increase in value. If you don't write compounding rate, people might think you mean linear rate, as in q times t, and not q to the tth power. And that's different. Oh, sorry about that. So we want to find the value of the painting in 2010. Okay. So we started at 1980. So how many years would it pass between that? 1980. That's gonna be 30 years. So t's in years, right? Yep. Okay, number of years. Okay. That means we have p times q to the 30, which using your values that you got for p, just use these. You can do 63110, or you could do absolute value, like the exact value. Okay, 10 to the 4.8 times 10 to the 0.05 times 30. That's going to be equal to, oh my god, 1,995,262.315. That's nearly 2 million. And we want to round it to the nearest 100,000 anyway. So you're going to take these guys and round that. So that's basically 2 million. 2 million pounds. Boom. There you go. Nearest 100,000. Nearest, if I can spell it, 100,000. Okay, next guy. A lorry is driven between London and Newcastle, and we have a function to calculate a cost as a function of the speed. Okay, I want to find the value that minimizes the cost. So, you know, minimums again, so you want to differentiate. So C is equal 1500, v to the negative 1, so that means over v, plus 2 over 11 times v, plus 60. My throat's really dry right now. If you differentiate that, d0 dv is going to be, well, you take this, times it by that, and then subtract 1. So you're going to get negative 1500. V to the negative 2 plus this goes away, so 2 over 11. And it minimizes the journey, so it's at a turning point, so the rate of change is going to be 0 temporarily, so you're going to want to make that equal to 0. So that negative 1500 over v squared plus 2 over 11 is going to be 0. That means 1500 over v squared is going to be equal to 2 over 11. So if you do v squared, it's going to be 1500 times 11 over 2. So v is going to be square root of that, which is going to be square root of 8,250, which is the 5 times square root of 330. Nice. I think you can leave that as the answer, or you can round it. Let's see what I did. I did both, and the rounded answer got ticked. So if you round it, that's going to be about 90.8. 90.836. And you want the minimum cost, so you want to sub in, okay? Sub in v is equal this guy into your original function for cost. So 1500 over 5 times root 330 plus 2 times 5 root 330 over 11 plus 60. And that is going to be equal, literally type into your calculator, it's just going to give you 660 plus 20 root 330 over 11, which looks ugly, but that is about 93.0 pounds apparently, if you round it to 366. Okay, cool. So you want to prove that it is actually a minimum, and when something's at a minimum, its second derivative is going to be positive, because it's trying to curve up, but right now it is at 0, but it's trying to curve up. So we want to differentiate that again, so you're going to get d squared c over dv squared. We're going to differentiate this guy, and that's going to be, okay, negative 2 times negative 1500. That's going to be positive 3000. V to the negative 3. That's it. So you want to sub in your value for v, which is 5 root 330. You're gonna get about, okay, wait, so v is equal 5 root 330. Okay, so d squared c over dv squared with that value is going to be about 4 times 10 to the negative 3, which is still positive. So this guy is bigger than 0, therefore it's a minimum. All good, all good. Okay, state one limitation of this model. Let's see what they're saying. It says the lorry is driven at a steady speed of v. When you drive between, you know, London and Newcastle, I highly doubt you can keep your speed the same for the whole journey. That's the limitation. So limitation is the model assumes speed is constant throughout the journey. If I can spell it. However, speed is likely to be changing during the journey. There you have it. Alright, next guy. Trigonometry. Show that the equation this guy can be written in the form this guy. Okay, so we have 4 cosine theta minus 1 is equal to sine theta tangent theta. First thing we can rewrite is write tangent theta as sine over cosine. So we're going to have 4 cosine minus 1 is going to be 2 sine over cosine. So we're gonna have sine squared from this, and then you can move the cosine to this side. So you're gonna have 4 cosine squared minus cosine is going to be equal to 2 sine squared. And at once it looks like they're all in cosines, so we're going to get rid of the sine by using sine squared is going to be equal to 1 minus cosine squared. Going to be using that. So 4 cosine squared minus cosine is going to be 2 minus 2 cosine squared. Going to move that to the other side. You're going to get 6 cosine squared minus cosine. You're going to move that 2. You're going to get negative 2 is equal to 0. Boom. There you go. Solve for this. So it looks like it matches perfectly when 3x is equal to theta. Right. So that means we can just use this version of the equation and then sub in theta is equal to 3x. So 6 cosine squared of 3x minus cosine of 3x minus 2 is 0. That looks like a quadratic equation because this cosine squared just means the cosine all squared. So let's solve it. You might, okay, I'm just gonna let cosine of 3x so that y is equal to that. Okay, so we have 6y squared minus y minus 2 is 0. You want to complete the square? No, just do this. Minus 1, so plus or minus, and then 1 squared minus 4 times 6 times negative 2 over 2 times 6. And you solve that, you're going to get negative 1. You're going to get 1, okay, plus or minus 7, because that's root 49 in there. So 7 over 12. So either cosine 3x is equal 1 plus 7 over 12, or cosine 3x is equal to 1 minus 7 over 12. 1 plus 7 is 8, 8 over 12, so it's going to be 2 over 3. 1 minus 7 is going to be negative 6, 6 over 12 is going to be negative half. Cool. Alright, so if you type into your calculator 3x is going to be the inverse cosine of negative half, which is it's going to be 120 degrees. But then, you know, if you remember the graph of cosine, it's kind of symmetrical in that way. If you have a negative half over here, and that's 120, there's also another solution here, where you have 180 here, yeah, and then you have 120, so the difference between that is going to be 60 degrees, so that's going to be the same difference here, so you're going to get 180 plus 60 degrees, which is 240. Because it wants us to solve in a range. What range is it? 0 to x to 90 degrees. So when 0 is smaller than x, smaller than 90 degrees, but we're starting with 3x right now, so we want to times everything by 3. 0 times 3 is 0. 3x. 90 times 3 is 270. So this is actually in the range because it's 240, so that's fine. And then we want to solve for this one. It's equal the inverse cosine of 2 over 3, which is some weird number. It's about 48.18969. Yep. Okay. But that's 3x. We want to solve for 1x. So you're going to divide everything by 3. We're going to divide this by 3. 120 divided by 3 is going to be 40 degrees. 240 divided by 3 is going to be 80 degrees. This guy divided by 3 is going to be 16.1 degrees to 1 dp. You always do angles to 1 dp unless you're working with bearings. So that's our 3 answers. Alright. Next guy, that's the last question. Ooh, it's the one I did wrong. Okay. So we have 2 graphs, one is C, one is L. Okay, we want to figure out the area. So obviously, you know, that's A, that's B. B is such a triangle. A is the area under the curve from 2 to, where's P? P is 4, 6, so that's going to be 4. Yep, 4, 6. Cool, and it says that L is normal to C at the point P. Okay, so we want to figure out the equation of L, because we want to figure out this point. So we have, okay, good, this is C. So we want to differentiate it with respect to x. So you get, so this is equal to 32 times x to the negative 2. So we want to bring this to here, so we're going to get negative 2 times 32, which is negative 64. And then we're going to bring the x down as well, so it's going to be negative 3 plus 3. So when we sub in x is equal 4, we're going to get 4 cubed is 64, I think. Right? It is 64, so we're just going to get negative 1 plus 3, which is 2. So that's the tangent, right? But L is the normal, so L is actually perpendicular to a line with a gradient 2. So 2 times the gradient is going to be negative 1. So then gradient of L is going to be negative 1/2. Because this is the relationship when 2 lines are perpendicular. So you have the gradient of the first line, gradient of the second line, times them together is equal to negative 1. Cool. So we have the gradient, and now we just want to sub it in and see what C is, because we have y is equal mx plus c, right? M is negative 1/2. Okay, we know a point 4, 6. So y is 6, x is 4. We just want to figure out c. So 6 is going to be negative 1/2 times 4. Oh, that's ugly. Plus c. So that's why c is going to be 8. I believe. Yep, C is 8. So now we want to figure out the x-intercept. So that's when y is 0. Well, y is equal to negative half x plus 8. And we want to make that 0. So 0 is equal to this. And you're going to get negative 8 is negative half x. So x is going to be 16. So this guy's going to be 16. So your integral, or your triangle, is going to be, well, height is going to be 6, and the base is going to be 16. So b is 1/2 6 times 16, which is 3 times 16, which is 48. Nice. Did I get that right? Oh, no, that's wrong. That's wrong. That's actually 16 minus 4, because you want the distance and not just the value. 16 minus 4, which is 12. So 3 times 12 is 36. Almost fucked that up again. So now the hard guy. Okay. So I want to integrate the curve. So y is equal 32x to the negative 2 plus 3x minus 8. You want to integrate this guy with respect to x from 2 to 4. So x is equal to 2 to 4. And you want 32x squared, negative squared, plus 3x minus 8 dx. That's going to be equal to, if you add 1 to this, that's going to be negative 1. And you divide this new negative 1. No, divide 32 by the new negative 1, so that's going to be negative 32x to the negative 1. You can check this by differentiating this and you get this back. Plus 3 over 2x squared, because this is x to the first power, you add 1 to that and then divide 3 by the new exponent. So he's going to get 2, and then 3 is going to be divided by 2. And then you're going to get minus 8x. Running from x is equal to 4, so you're going to sub in 4, and then you're going to sub in 2, and you're going to subtract the result of this from this. So we're going to get, when we sub in 4, what do we get when we sub in 4? When we get minus 16. Okay, that's going to be minus. When we sub in 2, we get negative. Oh, that's ugly. Okay, that's going to be minus 16 minus negative 26, which is positive 10. So the sum of the areas is 10 plus 36, which is 46. There you have it. Hope that's alright. I've been filming for 1 hour. My phone's probably out of memory.